Okay, class, let's go ahead and start on part 2. We are just going to practice a lot of these, and hopefully after this video, this will make a lot more sense. And let's start. So we have the square root of 6 times the square root of 15. Um, Again, there are multiple strategies. You could be splitting this into its prime factorization and circling the pairs. I'm going to go ahead and do that for the first one. But eventually, I hope we can start to see patterns where we don't actually have to do that, right? So I'm going to go ahead and show that the square root of 6 is square root of 2 times the square root of 3. And I know the square root of 15 is simply the square root of 3 times the square root of 5. So if I were to multiply all of these, the ones that have my attention are these pairs, right? The pairs are the ones that become whole numbers, and they jump out, and the square root of 3 and times the square root of 3 is technically the square root of 9. But we also know that the square root of 9 is simply just 3, right? So that's why we look for these pairs, because once we have the identical term multiplied by the other identical term all under the radical, it becomes the whole number version, okay? And then the square root of 2 times the square root of 5, they're two prime numbers under the root, and there's nothing you can do with them. You know that that's just going to be square root of 10. So our final answer here is 3 root 10. Go ahead and box it. Okay. This number 6, the square root of 400 divided by 5. Well, we're just dividing here, so I'm just going to go ahead and write the square root of 80. Okay. And luckily, I have these perfect squares on the side where I can determine what perfect square is a factor of 80. Okay. So I'm going to start from here because this is right where the square root of 80 would be. And obviously 64 is not a factor. 49, not a factor. Just keep going down the list. Always go from the highest possible number and keep going down. And you keep going down, 36 is not a factor. You start to realize 16 is that special number. You could have used 4 as well, but 4 actually would lead you down a route that is actually more time intensive and it requires more steps. So that's why you want to go from the highest possible, and you always want to go descending in descending order, right? This becomes the square root of 16 times the square root of 5. And I know that the square root of 16 is simply just 4. So my final answer is going to be 4 root 5. Now, we could also just double check just to make sure we understand what's going on. We realize that the 4 is equal to the square root of 16. So the square root of 16 times the square root of 5 would indeed get me back to the square root of 80, right? You just always want to make sure, like if I were to convert this number back to its square root form, is it going to give me the original 80? Okay. 3 root 5 times root 5, well, they already give us a pair right there, so we just know that that's going to be 5. And this is simply just 3 times 5, which is 15. So these are going by pretty fast. Okay, number 8, very, very good question. I honestly want to divide this up. I'll divide it into the square root of 124, and then I'll also divide it into the square root of y6wz. Very good question. Okay, so let's start with the square root of 124. What is a perfect square that is a factor of 124? And I'll be honest with you, 124, I don't really see it that often, but I'm going to go ahead and use my strategy of coming here and looking at all the perfect squares and seeing which perfect square is a factor of 124. So just keep going down. I mean, 124 is here. None of these numbers would ever be factors. They're not even over the 50% mark, or under the 50% mark, I should say. And 49, no. 36 kind of sounds interesting, but no. 25 is no. 16, ooh, that might be an answer. What's 16 times 8? No, 16 times 8 ends in an 8, so that can't be. What about 9? Does 9 work? No, 9 does not work. And you know what's funny? The only one that works is the square root of 4. So we tried our best, but hey, that's okay. Sometimes we might have to spend a little bit more time on these. This is the square root of 4 times, well, what's 124 divided by 4? That's just 31. And 31 is a prime number, so we're totally comfortable with saying that that's completely simplified. So our answer for just the number portion is going to be 2 root 31. Okay. Kind of tricky, but it's okay. Let's go now to the variable portion. Okay, we've seen this in the previous lesson, but hopefully you are comfortable and you start to realize you really just have to look at the power, the exponent, and divide that number by 2. We're dealing with square roots, so you want to divide this power by 2. If it's an even number, it will come out cleanly. If it's an odd number, there will unfortunately be 1 stuck inside, right? So it's really just how many pairs of each variable do we have? Right? We know that 7 is obviously an odd number, so there's no way that you can have an even, clean number of pairs. So square root of y6 is simply just y3. Square root of y7 is just going to be y, or sorry, not y, w is going to be w3, and there will be a w stuck inside. Okay, I'm going to go ahead and expand this to just explain why this is true. If I were to expand square root of y6, you get square root of y, square root of y. This is a little bit of time consuming, but and you're circling the pairs, right? So you circle this as a pair, you circle that as a pair, circle that as a pair. You realize, oh, there are 3 pairs. That's why I get y3. Okay, we're still not done. We're going to finally combine these 2 things. And this I'm going to write in red. We end up getting 2 as the outside term, the value, the coefficient. And it's going to be 2y3 w3 square root, and then you combine the square roots 31 and w. That was a lot of work, but hopefully that made a good amount of sense. Okay. At any point, if you have a question or if you want to review this lesson, obviously, you can pause. I'm going at a decent pace, but if you do want to take a breather right now and pause, go ahead and do that. Okay, let's start on number 9. 4 square root of 5 times the square root of 18. So if we were in class, I would ask the students to try to do this on their own, and I would try to get as many different combinations and many routes you can go. I think one thing that some people might be wondering is, Mr. Kuo, can I simplify the square root of 18? Should I simplify that first before I multiply these 2? In this case, I would say that is an excellent idea, right? The square root of 18 is the square root of 9 times the square root of 2. We know the square root of 9 is simply 3 root 2, or the square root of 9 is 3, so we know this is 3 root 2. And then, once you've simplified square root of 18, that's when you combine with these 2. So it really just becomes simple after that, because now I just take the 4, multiply the 3, and I get 12, and the root 5 times the root 2 is going to be the root 10. 4 root 5 was already simplified, which was very, very luxurious. Okay. And then here, Don't forget that you could always put the 5 on the side, right? You could almost even ignore the 5 for now and just attach the 5 later. So you just think, what is the square root of 600 divided by square root of 75? 75 goes into 600. Well, 75 times 2 is 150, and 150 goes into 600 4 times, right? So 75 times 4 times 2 is going to give me the 600. Essentially, this whole thing is 8. So it's 5 square root of 8, but we realize that the square root of 8 is not simplified, and you can split the square root of 8 to the square root of 4 and the square root of 2. This becomes a whole number. That's exactly what we want to see. This is just 2. So then you get 5 times 2, which is 10, and 10 root 2 is your final. Let's take a pause break.